So I'll show you some loops, and then I'll tell you that I don't want you to think about them as loops, and then I'll tell you why. Most of them look pretty innocuous, and even if you haven't seen Ruby, you can kind of figure out that says, oh, I see, for each of these array values, I'm going to pass it to this block, this procedure, as the parameter string, and I'm just going to print it out. That's pretty straightforward. Well, that looks pretty innocuous. I've seen for loops before. That looks like a range of numbers, and the variable is available inside the loop. OK, I understand that. Oh, this one's a little more interesting. 1 up to 10. Well, that's pretty cute. And then inside the loop, I can get the value of it as num. OK, so these all kind of looks like, here's another one. I can print rah, 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 3 dot times. And by the way, remember, if you've been reading the book, that braces are also, in some cases, an acceptable substitute for do end. So if you have an entire block or a function that fits on one line, sometimes you'll see it surrounded by braces. So these braces in the last example could be do and end instead of braces. That's what they stand for in this context. Again, if in doubt, use do and end. That's perfectly fine. OK, so these all kind of look like loops. But in fact, they're really all manifestations of a single underlying mechanism that's considerably more general. And the way that I usually sum this up is, if you find yourself writing explicit iteration with an index, like a for I loop, you're probably doing something wrong. Because the idiom in Ruby is to use iterators that allow objects to manage their own traversal. So again, if you're coming from the Java world, this is going to seem a little bit inside out. And we'll do a direct comparison in a moment. The examples that we just saw, one of them was about traversing a range. So I can take a range and say, for each item in that range, grab the item and do some stuff to it. I did up to, which has a starting point and an ending point. That was another way to do it. I could also have an array and say, each element in the array, I'll grab and do something with that element. I can take hashes, so I can do each key in a hash, or I can in fact do each pair, a key and a value together, which means that inside my block, inside the body of my do, I'll be able to have both the key and the value passed to me. And I did this really simple zero-arity iterator, which just said some number of times do something. So what do these things all have in common? They all have in common the inside-out iteration that Ruby does a little bit differently from Java. In each case, we're taking an object on the left, like a range or an array or a hash, and we are asking it via the method each to manage traversal of its elements and hand us the elements one at a time. In the case of each pair, we're actually getting a pair of things, a key and its corresponding value one at a time. But this is kind of different from the Java idiom where you say, initialize an iterator on that thing, and while the iterator has a next thing, give me the next thing, and now do some stuff and check again. And in a minute, we'll see why this is a more general mechanism that you can subvert for your own nefarious purposes. So some people call this expression orientation in Ruby, which means that I can now take collections of things, like this array. I can call sort on it. I can call unique, which removes duplicates, and I can call reverse on the result of that. So I'm sort of chaining these expressions together. And remember, none of these are actually modifying x, right? X.sort creates a new copy of x and sorts it. X.unique.reverse creates a copy here and another copy here and returns that. So these are actually all non-destructive methods, unless I use the dangerous version. X reverse, bang! That actually will reverse x in place. Right? And these are examples of methods where there's both a safe version and a destructive and unsafe version. There's map, just like there is in Scheme and Python and other languages. I can take an array like x, and for each element, a fruit, I can call reverse on the fruit. Now in a minute, you'll say, wait a minute, up here you were calling reverse on an array, but here you're calling reverse on what? Strings? Yes, in fact, we're going to get to that in a moment. That is the magic of duck typing. And we'll get that. You try to pronounce those words. We can collect, meaning select out the elements that match a criterion. We could say, for every element in X, manage your own traversal, hand me elements one at a time, and I'll just keep the ones that include the letter E. And I'll get back a new collection from this. So again, if you took the classic version of 61A with Scheme, this actually is a pretty familiar idiom. And by the way, remember when I said earlier on that even though things have classes, classes aren't that important. It's all about what do you respond to. That's the reason that reverse works on individual strings inside the array as well as on the array itself, right? So the Pavlovian bell should be saying, aha, what you mean is the array class defines a reverse method that reverses the array elements. But as well, The string class defines reverse to reverse the characters in a string. And to a first order, that's correct. We're going to modify it and refine it in just a moment, but that's actually the right way to think about it. I can ask whether any of the elements of x have a length greater than 5 and just get back true or false. So again, what's a real-life example of chaining one method after another after another? Let's go back to our friend Pastebin for an example. And again, don't worry if this code looks complicated. The goal is to get you accustomed to reading Ruby. This is admittedly not the most beautiful Ruby because I wrote it for myself. If any of you has the Bay Area Clipper card that's valid on all public transit, I have it. I use it all the time, and I like to be able to easily check my balance. And they have the world's worst non-RESTful website to do it. So I just wrote a scraper. I didn't reveal my Clipper username and password. But what does this do? Well, I'm using a great Ruby library called Mechanize, which is designed to behave like a scriptable browser. Right? It can pretend to do anything a human would do if a human were using the browser. So what am I going to do? This whole thing, by the way, starting from line 9 and going down to line 18, this is one statement. I told you this isn't beautiful code. This is me needing to get something done in a hurry, but it's real, so I'm trying to be honest. So I'm starting a new Mechanize session, and on that session I'm calling post to log into the Clipper card site. And on the result of that post, which is the body of the page that comes back from login, I'm looking for the link that has an href, an anchor, which is the card value. So this is where you would click and it says get card value. And on the result of that link, I'm going to click, which causes Mechanize to follow the link. On the result of that, which is another page, I'm going to create a parser object, on the result of which I'm going to look for some tags saying Clipper cache, which is the little thing that tells you how much money you have. And on the result of that, I'm going to call first, and then I have to traverse the HTML tree a little bit, find a regular expression that has $ followed by some numbers, and voila, I wrap it in HTML and it comes back. Again, you are not expected to understand this in double quotes, but what's kind of the key message here? Method chaining is hugely powerful. Right? I was able to essentially write a string of actions that looks like what I want to do instead of having temporary variables for each one of those steps. And although it looks a little intimidating when you first see it, once you get used to writing code this way, it goes much faster. So, if somebody comes back and says, I wrote 100 lines of Ruby this afternoon, they did a lot of work, right? 100 lines of Ruby is really concise. You can get a lot done in 100 lines of code. So that was today's not so beautiful real-life example.
Can I play devil's advocate and say, does it make it a lot more difficult to debug if you're chaining a bunch of things because it's harder to get the intermediate values?
So the question is, when you do this kind of chaining a zillion things, doesn't it make it more difficult to debug? The answer is yes, but I didn't sort of type all that code and then ran it and sat back and watched. Right? This was a trial and error process. I had to actually try intermediate steps, and I did some stuff in the terminal window. But the result of what I did is step, 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 because I optimized it to make it easier to read.